if we let students program robots that move in paths determined by individual groups of students, we will likely see robots moving in different manners, thereby exhibiting a sort of creativity in students. Of course, students can also learn a bit of programming, and making robots move along certain structured paths, like a straight line or a circle governed by mathematical equations, involve mathematics as well. We can also let a pair of students each program a robot to wrestle against each other, to engage them in more complex programming. This also involves science, because center of gravity in physics is a key consideration to bring one down to the floor. The wrestling process will certainly demonstrate creativity too. I am not saying that the above two robotic projects have no merits, and on the contrary, I find them interesting, engaging, and meaningful. However, how much would you think these two projects empower students to recognize how science and mathematics are used in engineering design to devise technology? In my opinion, quite little, and thus they are not really classic STEM courses as far as I can see. The technology lies deeply in the robotic system designed by the team of engineers of that company selling the robotic system, and little will be acquired by the students who merely do programming based on the framework of a fixed robotic system. There is also a class of microprocessor-based project work learning activities that are often referred to as STEM courses. For example, one such project work involved programming of microprocessor to control a lamp based on the reading of a nearby light sensor. The lamp will be automatically switched off when it is bright and automatically switched on when it is dark. This seemingly very difficult task can be accomplished by even primary school students, thereby making some parents proud and happy. However, if one doesn't use a microprocessor, but has to rely on basic circuits component and a photosensitive device to design a circuit that performs the intelligent lamp functionality mentioned above, the level of difficulty would rise tremendously. Not only that, primary school and secondary school students are mostly not capable of doing it, but high school students who do not have practical experiences in electronic design would also find it challenging. What is the difference between devising a microprocessor-based intelligent lamp system and designing a circuit with such an intelligent lamp functionality using basic circuit components? The fundamental difference lies in that the former involves only programming without having to carry out engineering design, while the success of the latter hinges on engineering design. So I would say that the latter fulfills the basic requirements of STEM to a relatively much greater extent. Let us ask ourselves this critical question: do we want to develop our students to be engineers capable of developing truly innovative products, like the robotic system or the microprocessor system? Or are we contented with our students being just a user of such a robotic or microprocessor system? If your answer is the former, then please consider adopting the classic STEM modules designed by ADAS.